There is an airport on this planet larger than an entire country. We're not talking about a few extra miles. We're talking about a territory that swallows sovereign nations whole. King Fahd International Airport in Saudi Arabia covers 300 square miles. The neighboring country of Bahrain covers 295. 5 Heathrow airports fit inside it, and there's still enough room left over for the entire Dubai International, a $2.6 billion project. 16 years of construction, and today, most of it sits empty. How did one of the largest airports ever built become the world's greatest white elephant in aviation? The answer is in the engineering and in the unchecked ambition of a project that dared to challenge the desert itself. But before we understand why it sits empty, you need to understand what it took to build it. If you're not subscribed yet, now is the moment. Hit like and ring the bell, because this project is going to blow your mind. The desert keeps its secrets. Let's go find them. The story begins in 1983 on the eastern coast of Saudi Arabia, a region sitting on top of the world's largest oil reserves and an airport that was already falling apart at the seams. Dhahran Airport was simultaneously serving military personnel, oil workers, and civilian passengers. It was an operational disaster with an expiration date. Air traffic across the Persian Gulf had tripled in under 15 years. Saudi Arabia needed a solution as large as its ambition. The solution was radical. Take a stretch of virgin desert and build the largest airport in the world from scratch. There was nothing out there. No roads, no infrastructure, no water source. Only sand, heat, and wind. In 1983, the machines arrived, and one of the most ambitious engineering projects of the 20th century began. 16 years of construction, $2.6 billion. A main terminal with 3.4 million square feet spread across 6 floors. The control tower stands 280 feet tall, the equivalent of a 28-story building rising out of the middle of the desert. 2 parallel runways, each over 13,000 feet long, wide enough to handle the Airbus A380, the largest passenger aircraft ever built. 13,000 feet of runway. For reference, most airports around the world operate with runways between 8,000 and 10,500 feet. And somewhere inside this complex, something almost no one knows exists. A private terminal, 176,000 square feet, built for a single family. The Saudi royal family has its own airport inside the airport. Absolute luxury. Rarely photographed. Almost never seen by the public. But behind all this grandeur, there was a problem the engineers knew about from the very first day of the project. The problem wasn't the budget or the timeline. The enemy was the environment itself. A desert that hits 122 degrees Fahrenheit in summer. Sandstorms that travel hundreds of miles, destroying everything in their path. And an unstable ground, dunes that shift position literally from one day to the next. To build here, engineers would have to solve problems that no airport manual had ever addressed. 3 villains, 3 simultaneous fronts, and engineering would have to answer every single one of them. Let's break them down. Starting with the most invisible and the most destructive. The first villain is thermodynamics. Saudi Arabia records surface temperatures exceeding 158 degrees Fahrenheit on asphalt during summer. Every solid material expands with heat. A 33-foot steel bar can grow over half an inch on a hot day. Across 300 square miles of airport, that effect is multiplied thousands of times over. The thermal swing is the real problem. 122 degrees by day, 59 at night. That 63-degree shift happens every single day, and it strangles structures from the inside. Picture a structure breathing, expanding in the morning, contracting at night, repeating that cycle for decades. Without the right expansion joints, the concrete simply fractures. Engineers installed expansion joints across the entire complex, gaps calculated to the millimeter to absorb that movement without compromising the structure. The second challenge was keeping the interior habitable. The KFIA's air conditioning system isn't central in any conventional sense. These are dedicated cooling plants, industrial cold factories. The energy draw from those cooling plants is equivalent to powering a mid-sized American city, just to keep the air conditioning running. The second villain has a name. In the Gulf region, sandstorms are called Shamals, winds carrying abrasive particles at over 60 miles per hour. For a jet engine, sand is poison. Microscopic particles enter the turbines, fuse with the heat from the blades, and form glass deposits that destroy the engine from the inside. That phenomenon has a name: CMAS, calcium, magnesium, aluminosilicate, one of the leading causes of engine failure in desert operations. The solution was as much landscape design as it was engineering. Designers planted thousands of trees around the runways, forming physical barriers against the sand. Each tree irrigated by desalinated water from the Persian Gulf. An underground irrigation network stretching for miles just to keep that green belt alive. Up to this point, these were challenges you'd expect from any major desert project. But KFIA had one engineering problem that no airport anywhere in the world had ever faced: a mosque for 2,000 worshippers, built on top of the parking garage, in midair. Islam requires prayers at fixed daily times. That meant the structure below had to handle 2,000 people in simultaneous movement, in unpredictable dynamic load. And that wasn't all. Less than 1,600 feet away, jet engines roar at over 140 decibels. The acoustic isolation had to be absolute. The solution was to build the mosque on a completely independent support structure, as if it were floating above the garage, decoupled from any vibration. The result? Silence inside the mosque. An A380 taking off just outside. King Fahd Airport was built for the icons of the sky. Grab this premium die-cast A380 model and bring the giants home. Link is in the description. But of all of KFIA's engineering challenges, the greatest one wasn't building it. It was justifying what was built. Only 5 to 7% of those 300 square miles are actively used for airport operations. The rest is desert behind a wall. The airport was designed for 30 million passengers a year. It operates with 10 million, 1/3 of capacity. That's where engineering meets economics and discovers that building too big carries a cost no budget can predict. 16 years after the first Earth was moved, King Fahd International Airport opened its doors in 1999. The opening was treated as a national triumph, a symbol of what Saudi Arabia could build when it decided to have no limits. The expansion joints held. The structure has been breathing for over 20 years without compromising a single pillar. The green belt held. During Shamals, sand loses momentum in the tree barriers and settles before reaching the runways. The desalination irrigation runs mainly in the early morning hours when evaporation is at its lowest, a small detail that saves millions of gallons a year. The suspended mosque became one of the most referenced structural engineering solutions in large-scale projects across the Middle East. The 200-foot wide runways operate without restriction for any aircraft in commercial service today, including the heaviest cargo jets in the world. But engineering solves physical problems. It doesn't solve demand problems. When the airport opened, projections called for rapid growth. Traffic grew, but never at the pace the project had assumed. Dubai, Doha, and Abu Dhabi built their own regional hubs and won the race for international routes and connection traffic. KFIA was left geographically isolated. Dammam is not Dubai. The transit passenger volume never arrived. And there lies the paradox. An airport capable of handling 30 million passengers a year, running at 1/3 of that, surrounded by hundreds of square miles of desert that were never used. The infrastructure is there. The runways are there. The cooling plants are running. The mosque is up there, in silence. Everything working, everything ready, waiting for passengers who haven't come. There is a lesson here that goes well beyond engineering. Heathrow is 1/5 the size of KFIA. It moves 8 times more passengers. King Fahd is a genuine feat of engineering. Every technical solution we covered here worked. The heat was tamed. The sand was stopped. The mosque floats in silence to this day. Engineering delivered what it promised. The problem lived in a question nobody asked before the first shovel hit the ground. For whom? Building the world's largest airport is an extraordinary achievement. Building the world's largest airport in the wrong place is a reminder that scale without strategy is just expensive concrete. Every project that pushes the limits of engineering deserves to be told. That's why this channel exists. If you made it this far, the algorithm needs to know. Drop a like, subscribe, and hit the bell, because the next episode is going to be even bigger. Epic Engineering Lab. See you in the next one.